ergonomics lab. And Jim, do you actually want to shut the door only because we have real engineers working out there today? Can you believe that? Yeah, come on in, because there's a couple seats if you guys want to have a seat. This is a motion capture lab, and we actually are part of the manufacturing engineering team. So where were you guys just now? Were you at the Vertec or at Elizabeth's? Vertec, okay. So you're down at product development. In product development, they're going to actually work on the components of the vehicle, and then you would release that component design into a team center, which is just a database. And what we do at manufacturing is we then are obligated to look at each of the components and make sure that it can be assembled. So we're like the instruction manual of the assembly car. And our customer is really the assembly plant. We need to process every step of how the vehicle is going to be built. We determine the heights at which the vehicle is going to run down the assembly line, orientations, and things like that. So what happens is we do virtual builds, and in a virtual build we'll come to a component and we'll say, I wonder if that can be assembled, if it's going to put stress on an operator when they're assembling that. We could then bring that component into the motion capture lab and into this ergonomics lab. And what we're doing here, I can have the next slide, is we then assess tasks that involve complex motions. So it's not that we bring everything here, but just the ones that are kind of tricky. We also do high profile studies here. So if we were asked to look at a strategy of where the antenna should be placed. So then we could bring in multiple vehicles virtually and determine the best location and strategy of where we would have the antenna located on all the Ford vehicles. So much more of a high-profile strategic development of specifications, and then even some research. Ford's been very aggressive on setting industry standards on what's acceptable for assembly line workers from an injury standpoint and things like that. So what happens is passive optical capture system. The cameras are all looking for reflective markers. It's just the same material as you have in your jogging equipment, so that the cars don't get you. So the camera is actually looking for this cloud movement. We also have a head-mounted display and wireless data gloves should we actually want to get into some fine movement. Today we're just going to use a hand as a solid entity. Next slide. You can put as much amount of props. So the great thing about using motion capture, which we borrowed a lot from the movie industry, is you don't have to have a new Fiesta in here. I don't have to wait for a prototype. I can just use hard points. So I can create this and it will match the virtual data set. And you'll get to see a little bit more of that in a few minutes. So that has saved us millions in not needing a prototype vehicle. Next slide. So then we would marker someone up. So today Glenn has been volunteered to be markered. The markers are put on components of the body, the leg, the knee, usually the joints. And then in the camera system, if you can go to the next slide. Yeah, next slide. We basically have the marker system next, and then the camera's picking up and we get a cloud path. So then the tricky stuff comes where the technology then says we need to take these cloud markers and match them to an animation. In this case, the animation is actually a digital human model. And inside that digital human model, there's a lot of science. So that when we make the arm move of Jack, if you could move, so it's capturing these clouds. Jim Chang is running it, and Rico back there, they've made the clouds be the hand and the elbow. And so as Glenn moves, the digital human model moves. If you were making a movie, you wouldn't have to necessarily transfer that cloud movement onto a digital human model. You could make it go onto Shrek or any of those other animations. So this is just capturing the motion, and then the science is we put it onto this highly sophisticated model. And some of you may have seen the release yesterday on Santos. These are models that give us the answers, so that when Glenn moves into different postures, the digital human model can tell us, oh, that's a little bit hard, compressive on the spine. That could be at an elevated risk of injury if you have to bend and twist in those kind of manners. So that's kind of how we use the technology, bring it in. Oh, yes, we do. Okay, that's the future one. You mentioned this. Oh, yeah, go ahead. So this is one of the ones. Oh, you have to go back. This is the Santos one from yesterday.
Santos must be aware of the dynamics associated with full body movement.
Department of Defense and University of Iowa and the Virtual Soldier Program, because the same issues of what are the tolerance of the human is of interest to the Army, right? I mean, what we want is a really good science inside that digital human model, so that when we make it move and simulate, we can then use that data to say, is this acceptable? Some of the challenges we have in automotive is the guys need to do it car after car, about once a minute. So when we bring them in here to study, we actually set some of our limits knowing that there's going to be a high frequency of these postures. So let's bring Glenn in and show what we would do in a study. So today I have a study that is on the Ford Fiesta, and I want to know whether or not Glenn could reach an electrical connector, a hose, and a cap. So he would actually move forward and reach out to them. Jim's going to just give us a view and touch. And then we would be then capturing this posture. And then I calculate the stress on this shoulder and things like that. You're going to say, well, it's not very stressful, and you're right. But there will be a hose there, so put your hand on the hose. So, wow, you just got a new Fiesta there. That's very exciting. I was going to say, what happened to that Fiesta? So in this hose, you're going to say, oh, that's not too bad of a posture. And I would say, absolutely. I'm working 2 to 3 years ahead of this being in the assembly line. So what I can do now is say, back calculate, if this hose is here, and Glenn's going to push it on like that, what is the maximum force that we can apply to that? So we can use the biomechanics within the model and say, in that posture, it can't exceed 17 pounds of insertion. And then that becomes the specification or the target that we then bring to the engineering team and say, okay, great location, no problem, we can reach it, but you can't exceed 17 pounds. So it's really now made by being able to get a glimpse into the future of how someone would build the vehicle. We come to the party with the engineering community as a team member that is putting some constraints that protect our operator. And now, one of the bonuses about protecting the operator, one, we don't injure them. That's the injury cost. There's always a good. The other thing that we found is it means every electrical connector can be put on every time on every vehicle. And that's one of the things we're really, really seeing is that our quality has been really impacted because of the efforts that we're doing in the planning of the assembly line. So, I'm going to kick Glenn out because he's a good jack model. And I want to give you guys an idea of virtual reality. I'm going to immerse you in, we're going to use the head-mounted display, and you're going to see the Ford Fiesta, and I'm going to get you to reach the electrical connectors and things like that. I'm not going to do a full body, but we're going to do hands and head. So you're going to be a floating head, if you can see here, and a floating hands. All right. You want to give it a try? Yeah. All right. I think we should be able to get all of you through. So
Roughly 3 to 3.5 years before job one. So if you take, for example, our Fiesta that obviously we're very proud of, we can't wait till it gets out there. It is an 011 model year code that is for sale in 010, and that's typical for any OEM. But then we also ran these studies back in 2007. So the beauty of this technology is that you want to identify misses or mistakes or failures early. The big challenge that you get is, you can imagine if we're all standing in a pilot plant roughly 14 months from job one and somebody says, I can't do the hose, and we run the assessment, we go, you're right.
There. Do we want him out further?
You tracking me?
Okay. Your
So you
eyes
can
should
imagine
be
that
closed,
we're
only
standing
because
and
if
we've,
you do
the
some
hoses
back
have already
and
been
forth
built by the
straight,
supplier,
and then you get a
and,
little
and
bit
they're
like,
being
"Ooh,"
ready to go to the assembly
like your,
plant, and we're hoping to
little roller
build
coaster
a
ride,
quarter
like the,
million units, and we've got
Is that the roller coaster? So you
250,000
just
hoses made,
So like
and
I
somebody said,
what-
we
what
can't
you
do
do
it,
is
and
you
we
take the
study it, and we
cloud map
confirm that we can.
markers and you
What
put
we
them on
really
top
like with
of
this
a
idea,
figure.
although it is a
So what's
negative
happened
that
is
we found a
somehow
failure, you want
in
to
the
find it
mapping
very
of
far
the cloud
upstream, because
marker
if you go
to
to
the
a
figure
supplier
of the
and a
head,
design and
we
release
lost it.
engineer, sorry,
So, come in,
more?
more, okay, we need Glenn
See,
in
really,
here,
it's all
'cause
about
he's
me.
got all these markers on,
You are the markers, you're in charge.
yeah? Did she open her eyes yet? She's gonna fall asleep or on us. I think you can open her, we just don't know what you're seeing, what are you seeing? Just a nice,
I see that one that was up there,
okay,
another car, I see the car.
there you go. Gonna get your head on right, look at that, she just left her head lying around there. You know that saying your mother used to say, you'd forget your head if it wasn't attached, there you go.
Jill does a lot. Am I okay here, Jim? Fine. So we've got the hose that fails. What we study here then, you can imagine then if we studied a hose in 2007, then you're giving the
You want her
design
to
and
put her
release
hands
engineer
on
and
it
the
and keep it
supplier
still for
a
a
lot
second,
of
Jim?
time to redesign the
Okay, so put your
hose,
hands
redesign
onto
the
here,
port,
and
and
then
the
he's
earlier
going
you
to,
identify it, typically the cheaper the
try and
cost is to the
get
redesign.
the
If you want to
12 marker
redesign a hose,
on
12
to
months before
that.
job one in a
There's
system,
too
there's a
many
lot
in
of
the tester
retesting,
zone, or you
recrashing,
doing good?
performance issues, costs. But if you identify a challenge
You
3
have a
years
rough day.
before job one, it's just logical.
Of course,
You've given everybody
right?
far more time
So what
to
happens when you
assess
go
it and
live
fix it.
demo?
So that's really one of the key things here is that we're identifying a lot of things far earlier than ever before. And not just ergo, all the assembly feasibility. We always like to say our customer is the person that builds the vehicle, whereas, you know, the other places you're visiting
Wow.
today, their customer is the person that buys the vehicle. Both very important customers, but we really like to say that if we can get it right for our customer and they can do it efficiently, safely, with high quality, minimal labor costs, that's the whole assembly feasibility side of things. The last thing we want to do is hurt people in our plants, so we've seen a nice reduction in our injury and compensation costs. But it's also kind of common sense engineering that if an operator finds that the electroconnectors and the clips and the hoses are all within design specs, then it is far easier to build the vehicle. You don't fatigue as quickly. And let's face it, we're dealing with an aging population. We still have a significant percentage of women in our plants, and so we make sure we design for the small female to the tall male. So what you'll see in here is that we'll use a 95th percentile male hand, so the guy's roughly 6'2", and we'll make sure that if his hand can fit in to put in a plug, a cap, then all the smaller people can. And then from a reach perspective, we'll use Jill, and Jill's roughly 5 feet tall, and if Jill can reach, then obviously anybody taller than Jill can reach. So that's how we use the avatars or the mannequins here. We'll use Jill, and we'll use Jack.
So how many
So the
items
actual
on a
thing is
specific
the
build
same
will you guys
technology,
test
same
for?
thing as a motion capture.
What we'll do is statically using our Jack software, we'll assess every new part. And so every new part for reach, hand clearance, and
Okay.
strength. But we don't ignore the
All right,
carryover.
Glenn, I was just gonna say, I'm gonna do a little demo
You
here.
also have the mock-ups you're
so
testing
if you wanna
too,
reach
beyond
out
virtual,
with
right?
your, okay,
Yes,
you're gonna do left
so
hand
when we
with
get
your
to,
cap
we
there.
also will
So
do
there's a
all of our
cap
ergonomic
way out
studies
front
or
of you. So
restudy.
lean in
When we
like you're
get
an
to the
assembly
physical
worker,
prototype
and you're
parts,
going
we'll
to
make
that
sure
blue
that what
cap.
we were given upstream to assess
You're right about
actually
there. Where's
is
your
the
head?
way we're going to build it.
Where's
Because
your
the
head?
minute you have a disconnect,
Do we have too many
that
people
we
here?
thought the vehicle would be at this height, at this workstation with this part, and then you get to the plant and go, no, the vehicle's 2 feet shorter, that changes everything. So the good news is we're really picking out that stuff early and looking for those disconnects, because you don't want that surprise and delight later on. You really don't,
Good,
so.
and then maybe right in the middle, there's that
No,
hose.
no, it's not delightful for anybody. And then, of course, the question gets asked, how did you miss it? So what we'll make certain to do is we'll look at every new part, but then we'll also double check with the assembly plant, because the term carryover
that
can
the
be very
engineers are
misleading. On
releasing
one
on a
hand, it's great
day-to-day
from a
basis,
business perspective. If you've already
and
paid
you
for the
get then
tooling costs
actual
for a part,
location,
and you
and this is
reuse
then
that
where we
clip
would use
again
for
and again and
hand
again,
collision,
just
make
makes
sure it's
sense.
not hand
But
clearance,
if the clip
and
is a
things like that,
major
as
problem
well
to
as
the
doing
assembly plant,
biomechanical
we'll
analysis
always be in touch with
of
the assembly
insertion
plant, and we call them
forces
high
and things like
hertz.
that.
We'll say to the
All right,
plant,
getting a
okay,
feel for
what
it
are your
there?
10, 20,
All right, I'm gonna
30
bring you out so
worst
we give,
ergonomic jobs?
another,
Where do
try
people
here.
find
See
can't
while it's
reach it,
capturing.
can't keep
It's
up,
the thing
too
that
much?
you guys always
You were in
complain
reality, you
about.
were in virtual reality
There
for a
are,
while.
there are the
Woo-wee,
Wendy
come back.
whiners and the Chuck complainers of the
someone else
world
wanna
that
give it a try?
everything
All right,
is always
come on.
wrong. So we'll always look at those jobs though,
One of
we'll
our
assess
Ford
them, and if we
people
find that
take,
there's
you
a
want your video taken,
carryover
Mom?
clip, but it
You all right?
fails our spec, we're not very popular, but we'll go back to our product
yeah,
design
that's
folks
good,
and go,
yeah,
you know
yeah.
the clip you were planning on carrying over? We don't accept it. Well, what do you mean you don't accept it? We've had that clip on the vehicle for
Okay,
years.
so do you want me
Yes,
to,
and the plant has struggled
put it
for
back
years
here?
to get the clip removed. Our window of opportunity has opened up, and we are
It's
now
up
going
on
to
the
fix
thing?
this clip.
Hang
It's
on,
not
okay,
very
is it on
popular,
and
but
on?
it's the right thing to do.
Costs a lot of money to open a drawing.
Okay, put that on.
And that's the beauty of this, is that when you are trying to create these changes, you're not
What do you want me
changing
to do?
physical parts, you're changing
Move
drawings,
to
you're
the left
updating
a little.
CAD.